Welcome to this explainer. Today, we are diving into one of the absolute most fascinating mysteries hidden deep within our planet's history. So, for decades, scientists have been tracking massive, world-changing events in Earth's past. We're talking mass extinctions, truly massive volcanic eruptions, and dramatic climate shifts. But here's the thing. What if these weren't just random, isolated disasters? What if our planet actually beats to a hidden harmonic rhythm? Well, that is exactly what we are going to uncover today. We're looking at a groundbreaking new hypothesis that finally attempts to explain the cross-domain harmonic cycles for planetary systems.
Here is our roadmap for today. We're going to cover the mystery, the model, the measurement, falsification, and we'll wrap up with the real-world meaning. Let's get right into it. All right, Section 1, the mystery of Earth's deep past.
I really want you to just think about this question for a second. What if mass extinctions, massive climate shifts, and gigantic volcanic eruptions all share a single planetary heartbeat? I mean, it completely challenges everything we usually assume, right? We tend to think of Earth's biggest, most destructive events as totally random accidents. You know, a bad day for the dinosaurs over here, a random volcanic winter over there. But evidence has actually been building that these massive events might be clustering together on a strict schedule. So, the core problem in our existing understanding is basically this. The old view treats Earth systems like a bunch of completely isolated events. The oceans do their thing, the volcanoes do theirs, and life on the surface just tries its best to survive. But the totally new question scientists are asking is whether these major events are actually coupled expressions of a synchronized planetary megacycle. Instead of acting all on their own, are they literally tied together? When we talk about major Earth transitions, we're looking at massive stuff. Extinction events, shifting tectonic plates, volcanic eruptions so big they can literally pave entire continents in miles of solid lava. We're talking sea level changes and even the magnetic poles completely flipping. Historically, scientists studied these things as if they were solo musicians playing in completely separate rooms. The volcano experts studied volcanoes, the fossil experts studied extinctions. They never realized they might actually be listening to different instruments playing the exact same song. Moving right along, Section 2, the model. Let's see how we might solve this mystery. Enter a really bold new idea. It's called triune harmonic dynamics, or THD for short. This is a novel, falsifiable hypothesis proposed by researcher, inventor, and author Kevin L. Brown. And this framework suggests that Earth's major multi-million-year transitions, those cross-domain harmonic cycles we mentioned earlier, are actually organized by a shared, synchronized rhythmic architecture. So instead of random chaos, Earth's systems are following a deep underlying beat. To wrap your head around Kevin L. Brown's model, it helps to think of a 1 to 2 to 3 planetary rhythm. Just like an orchestra playing in perfect time, Earth's incredibly complex systems, all the way from the deep mantle up to the atmosphere, might phase lock into a shared mathematical beat. They aren't just happening at the same time by total accident. They're physically syncing up. They're harmonizing with one another in a way that is mathematically predictable. Okay, so it starts with the fundamental rhythm. According to Kevin L. Brown's hypothesis, the baseline cycle is roughly 27 million years long. That is a massive stretch of time. And over this 27 million years, deep structural pressure slowly builds inside the Earth. This is basically the master beat of the planetary orchestra, the deep drums setting the pace for the whole shebang. Following, right on the heels of that master beat, is the second harmonic, a roughly 13.5 million year cycle. Now, this isn't just some random number pulled out of thin air. Notice that 13.5 is exactly half of 27. It locks right into that 27 million year master rhythm, perfectly dividing the cycle, just exactly like musical notes dividing a measure of time. And finally, we have the third harmonic at roughly 9 million years. And you guessed it, 9 goes into 27 exactly 3 times. This completes a perfect 1 to 2 to 3 frequency relationship. This right here is the absolute core of triune harmonic dynamics, a 27 million year fundamental beat, a 13.5 million year half beat, and a 9 million year third beat, all locking together perfectly. So how does this actually play out in real life? Well, the model predicts the Earth goes through 3 recurring states. First up is emergence, where background conditions slowly evolve and invisible stress begins to accumulate deep down inside the planet. Second is contrast. This is where things really heat up. Interactions among tectonic plates, volcanoes, and the climate start to clash and push against each other. And finally, integration. The pressure peaks, causing a large-scale transition or planetary reorganization. This is exactly when you see your mass extinctions or your massive lava flows. The planet literally releases the stress and hits the reset button.
Okay, section 3, the measurement. How do we actually test this planetary pulse? We aren't just looking at one single piece of evidence here. To validate this hypothesis, scientists have to find a shared heartbeat across a massive variety of totally distinct Earth records. They have to measure sea level variations, massive continental volcanism, biodiversity and extinction rates, the flipping of the magnetic poles, and tectonic plate shifts. They basically have to gather all this wildly different data and see if it's all syncing up to that 1 to 2 to 3 beat. To figure this out, Kevin L. Brown laid out a really rigorous 4-stage validation test. Step 1, gather the data for all these Earth systems completely independently, without any bias. Step 2, run a spectral analysis. This is basically just scanning the data to find the hidden frequencies, kind of like turning the dial to tune a radio. Step 3, test to see if those frequencies are actually harmonizing and syncing across the different systems. And Step 4, see if this harmonic model can actually predict major Earth transitions better than the old models could. All right, section 4, falsification. How do we prove it wrong?
Now, this is a crucial part of good science. Kevin L. Brown explicitly built strict falsification parameters into his hypothesis, proving it is a truly testable model. If that 1 to 2 to 3 rhythm isn't mathematically there, the hypothesis fails. If the rhythms are only found in one thing, like, say, just volcanoes but not extinctions, it fails. If the math completely falls apart when scientists use better geological dating, it fails. It's a remarkably bold hypothesis because it leaves itself completely open to being proven wrong by the data. And this brings us to the comparator challenge. In science, you don't get points just for being complicated. If an older, simpler model of independent random cycles explains the data just as well as this new harmonic model does, then Kevin L. Brown's hypothesis is totally rejected. It literally must perform demonstrably better than the old way of thinking, or it just gets thrown out. Finally, section 5, real-world meaning. What does this mean for the future of science? Validating this would completely shift our entire focus. Instead of studying single, isolated events, scientists would be looking at a unified planetary architecture. Think about it. It allows us to identify windows of high structural planetary pressure. Basically, times when the Earth is literally winding up for a major transition. It would drastically improve our models of deep-time climate behavior and completely redefine how we understand the relationship between volcanoes, oceans, and the survival of life itself. We would finally be seeing the whole orchestra, instead of just listening to individual instruments. This represents a massive paradigm shift for the scientific community. It moves us from asking a super narrow question, why does each Earth subsystem have its own random cycle, to a unified, genuinely groundbreaking question, what planetary architecture coordinates them all? It changes the Earth from a series of random accidents into a highly structured, synchronized machine, which leaves us with one final, incredibly fascinating thought to ponder. If Kevin L. Brown's triune harmonic dynamics is correct, if the Earth really is a synchronized orchestra perfectly keeping time to a 27-million-year beat, what exactly is winding the clock? Is it something deep within the Earth's core, or is it something else entirely? The test is out there, waiting for the data to speak. Thank you so much for joining me for this explainer, and remember to always keep questioning the world around you.